Okay, so now that we have written all the code, what we want to do is we want to run our spider. So to run our program, Scrappy has a specific command that you gotta type here. It's Scrappy crawl and then the name of your spider. So in my case, it would be Amazon spider. And you can pass in additional arguments to essentially give the outputs a specific format. So in my case, I'm gonna just send a test.csv. So you're going to see a lot of information going through the screen. I currently have it set to debug mode, so it's going to be giving me a lot of information in addition to all the different rows that I am currently scraping. So you can kind of see that's happening, some of this information that's going through. So while that's running in the background, I'm going to be going again to the PowerPoint. So at the end, Scrappy should show some statistics of the project and how it resulted. So you can see some stuff like how many requests were rejected, how many of them were successful, how many responses you had, how many bytes you read, a lot of kind of useful information in case you're trying to debug things. So when I first started running through my Scrappy project, I noticed that there were a couple of rows that were missing from my output CSV files. I looked into it and I saw that Amazon was essentially blocking some of my requests. I was wondering why, so I did some research and I found that there were a couple of different ways that websites like Amazon can block different requests and how they go about doing it. So not all companies want to have their public data scraped, and they have to be very careful of potential denial of service attacks and bots that can slow down their sites. So they implemented these three main techniques that I'm going to talk about. There's a bot detection algorithm, which is essentially a program that runs and goes through every single request and tries to do essentially machine learning to identify who is actual human user and who is a bot. A very simple example of this that it can use to identify them would be like the speed of clicking. So a bot goes through a website very quickly. Most users can't really click at that speed, so it's able to quickly identify which are bots and which are not, and then block those specific users from using the site. Another technique that a lot of sites use are CAPTCHAs. These are very difficult to get through whenever you're building a spider. Thankfully, they are a little bit cumbersome to the user experience and they're not typically used. So they are almost always used, however, for like whenever you have to log in or things that are like high security. But in that case, web scraping will become illegal, so we really shouldn't care about it anyways. And then there's honeypots. I did not come across any honeypots on Amazon site, but many other sites tend to employ this. So they essentially make invisible elements that only bots would be able to run through and like go to different sites on those elements. And that is like a quick dead giveaway on what is and what is not a bot. Since most users would really not be able to see those elements in the first place. Okay, now I want to talk about some other web scraping drawbacks and tie a couple of things together. So web scraping code is not really modular. It requires tailoring to a specific website. You can kind of see that from the project that I was building. There are specific elements that I'm searching for here. Now, if the website were to change, then I would have to change these elements altogether. Not to mention, I would have to build a completely different application for different websites, right? Another issue that I ran into for different websites, you might have like different interfaces, so you might have to write like multiple spiders and have multiple items. For my specific example, Amazon has like a different interface for movies than it would have for like shoes. So if you type in here like shoes, well, not in Prime Video, and you click in shoes, this is like a completely different interface like I mentioned. So that would require a little bit more coding. So there's also the bot and anti denial of service attacks that these websites might use that I spoke of in the previous slide. To kind of deal with some of these, we have to have like multiple user agents and multiple proxies so that we can essentially rotate between different what looks like different users to the site, so that it's not able to detect that we're actually doing requests all together really quickly. This goes back to now I can go back into some of this code that I said I was going to talk about. The middlewares for our Scrappy project is meant specifically for that purpose. It's essentially kind of like the code that you write in between doing some of that scraping. So for my specific example, I don't really use any of these. Instead, I disable that in some of the settings, and you can kind of see that I just set none because I don't want to run it. And then I use my specific random agent middleware. And it's very simple. All it does is it gets this user agent list and then rotates through these different headers, and that would be located like here in user agent list. This is something that you kind of saw a little bit in the beautiful soup example for the headers. So I would only be using one header in my beautiful soup. However, there are multiple headers that I can rotate through, and this makes it look like I am actually different users instead of just one user rotating through many different headers all at once. So this will speed up things a little bit, and it will help me collect data without being detected by the bot detection algorithms that Amazon has. Even so, I still have to add a download delay of like around 1 second, specific for what I'm going to be doing here on the user agent list, because otherwise it would rotate through these lists too quickly, and then the bot detection would trigger and deny some of my requests. So that slows down things a little bit more than I would like. And then another issue that I ran into was that Amazon only returns 100 results, so I'm a little bit limited in my scraping ability for this specific site. This can be resolved potentially by having multiple queries and then filtering the data of duplicates when I combine those queries together. Overall, while scraping can be a little bit complicated, I definitely think it's worth it just because it has a lot of potential uses. You can use it on essentially any other site that you can think of, and it allows you to collect information and really use it for practically any analysis that you would want to do. So now I'm going to go a little bit of a short analysis on kind of like the data that I collected. Okay, now to close out, I have a short analysis that you can do on some of this data. I have that in Jupyter Notebook. So we skip through our beautiful soup example. We can see that there's some, I wrote some code here to essentially clean up some of the data on the women's shoes CSV. We're going to be getting some of the numeric data, getting some statistics on it and showing it, plotting it out. We can see that the price tends to average $40 for each shoe, or pair of shoes rather. And then there's I also made some correlation data on it. Unfortunately, I did not find very strong correlations. Moving on, I figured I could also do some NLP on some of this data and essentially look at some of the bullet point data. To show you an example, this is kind of what it would look like. At the bottom, you can see that there's inboxed out some of the bullet points that I would be going through and doing some NLP on them. So I do the standard thing that you would do for some of this data. You clean it up, tokenize it, remove some stop words, and then I wanted to look at the frequency of words here and the ones that are most frequent. I plot it out here. You can see that there's this specific for the woman bullet points. And then I also repeated the same exact process that I did before for the men's. I collected some statistics, plotted it out, and then I got the bullet points frequency for the men. Something that I noticed that was interesting here was the woman's bullet points seems to have words like soft, used for marketing, while for men they don't really use that word at all. So, and that doesn't have the largest of implications. However, I figured I could do some analysis, some short analysis on some of the data that I had collected. So these are the charts again on this slide. And so we had some data in the background that I was running. We can check to see that I have it here. There's like a test.csv. And if we open it up, we should be able to see some of the information that we had originally done a query on. So I believe our specific query was on women's exercise shoes. So we can see like Skechers, Brooks, all different exercise shoes here. And we only had a couple of empty rows here. This is all thanks to the circulating user agents and slower rate that I'm doing my requests. Okay, that's all for now. Thanks for watching.